After studying this module, you shall be able to know the simple Keynesian multiplier in an economy, understand the different impact of tax imposition on multiplier, comprehend the balanced budget theorem, understand the concept of budgetary surplus, know multiplier in an open economy.
Let us begin. The government uses the fiscal policy to correct the deflationary gap. It does so by either increasing the expenditure or cutting taxes. This has a multiplier effect on the economy. In this module, we study the multiplier in a three-sector model, including the lump sum tax model and proportional tax model. It also talks about the change in income tax on the equilibrium income. It discusses the budgetary surplus and also the multiplier in an open economy.
We will now learn about the multiplier in a three-sector model. The existence of a deflationary gap in an economy calls for the government to play an important role in increasing aggregate planned demand. The government affects the level of equilibrium income through its fiscal policy. Fiscal policy is the policy of the government with regard to the level of government purchases, the level of transfers, and the tax structure. Government purchases of goods and services, that is G, are a component of aggregate planned demand and is assumed to be exogenously given at a constant amount G. In a three-sector closed economy model, planned demand is given by AD is equals to C plus I bar plus G bar. This is given as equation 1. Consumption C will no longer depend on income but on disposable income YD. Disposable income is net income available for spending by households after receiving transfers from the and paying taxes to the government. We assume that the government makes a constant amount of transfers R bar. We consider two cases. Case 1, lump sum tax model. In this model, disposable income is given by YD is equals to Y minus T bar plus R bar. This is equation 2, where lump sum taxes is equals to T bar and transfer payments is equals to R bar. Consumption function is now given by C is equals to A plus BYD. C is equals to A plus B R bar plus BY minus BT bar. This is equation 3. Hence, planned demand equation using 1 and 3 is given by AD is equals to A plus B into bracket R bar plus Y minus T bar bracket close plus I bar plus G bar, or AD is equals to A plus I bar plus G bar plus BR bar plus BY minus BT bar, or AD is equals to A bar plus BY. This is equation 4, where A bar is equals to A plus I bar plus G bar plus BR bar minus BT bar. At equilibrium, AD is equals to Y. Hence, equation 4 can be rewritten as Y is equals to A bar plus BY, or Y is equals to 1 by 1 minus B into A bar. This is given as equation 5. The aggregate demand schedule is given by equation 4. Introducing the government sector increases planned demand, which results in an increase in equilibrium output levels. the magnitude of increase in levels of equilibrium output for a unit change in autonomous expenditure and taxes is given by the respective multipliers. Using equation 5, y is equals to 1 by 1 minus b into a bar, or y is equals to 1 by 1 minus b into a plus I bar plus g bar plus br bar minus bt bar is given as equation 6. We can derive the value of the following multipliers. Government expenditure multiplier is equals to alpha g is equals to delta y by delta g is equals to change in y by change in g, or alpha g is equals to 1 by 1 minus b. This is given as equation 7. Tax multiplier is equals to alpha t is equals to delta y by delta t is equals to change in y by change in t, or alpha t is equals to minus b by 1 minus b. This is equation 8. Transfer payment multiplier is equals to alpha r is equals to delta y by delta r is equals to change in y by change in r, or alpha r is equals to b by 1 minus b. This is given as equation 9. Looking at equations 7, 8 and 9, some statements are made and proved. Statement 1. Tax multiplier is always 1 less than the government expenditure multiplier. In other words, to achieve a given increase in equilibrium level of income, the required fall in lump sum taxes is greater than the required increase in the government expenditure. The reason is that when government expenditure increases by a certain amount, change in G, it increases planned aggregate demand directly by the same amount in the first round. It is then followed by successive rounds of increases in induced consumption demands. Hence, total change in aggregate demand is given by change in AD is equals to change in G plus B into change in G plus B square into change in G, and so on. At equilibrium change in aggregate demand must equal change in output levels. That is, change in AD is equals to change in Y. Hence, change in Y is equals to change in G plus B into change in G plus B square into change in G plus, and so on, or change in Y is equals to change in G into bracket 1 plus B square, and so on, bracket close, or change in Y by change in G is equals to 1 by 1 minus B is equals to alpha G, which is the government expenditure multiplier. This is given as equation 10. However, when taxes fall by a lump sum amount, it does not directly increase the planned demand by the same amount. Fall in taxes first increases the level of disposable income by an equivalent amount. This rise in disposable income then increases consumption demand by marginal propensity to consume times the change in disposable income. Some part of this increase in disposable income is saved also and not consumed. Hence, change in aggregate demand in the first round is B into change in G if change in G is fall in taxes and increase in disposable income. Successive round will bring introduced increases, that is, change in AD is equals to B into change in G plus B square into change in G, and so on. In equilibrium, change in AD is equals to change in Y. Hence, change in y is equals to b into change in g plus b square into change in g, and so on. Adding and subtracting change in g gives change in y is equals to change in g plus b into change in g plus b square into change in g plus and so on minus change in g, or change in y is equals to change in g into bracket 1 plus b square plus and so on minus 1, or change in y is equals to change in g into 1 upon 1 minus b minus 1, or change in y by change in g is equals to alpha t is equals to alpha g minus 1 using equation 10. Now hence tax multiplier is 1 less than the government expenditure multiplier. Statement 2. Balanced budget theorem. If the government follows a balanced budget, then tax financed increases in government's expenditure results in an increase in equilibrium income levels by the same amount. In other words, the balanced budget multiplier is equal to 1 in a lump sum tax model. Say, government increases its expenditure by change in G. Then change in equilibrium income is given by change in Y is equals to 1 by 1 minus B into change in G. When government follows a balanced budget, taxes also increase by the same amount, change in G. Then change in income is given by the tax multiplier and is equal to change in y is equals to minus b by 1 minus b into change in g. The total change in income is 1 plus 2, that is change in y is equals to 1 by 1 minus b into change in g plus minus b by 1 minus b into change in g, or change in y is equals to 1 minus b by 1 minus b into change in g, or change in y by change in g is equals to kbb is equals to 1. Thus, balanced budget multiplier, which is kbb, is equals to 1. Now we consider an economy with proportional tax structure. Case 2. Proportional tax model. In this model, the government collects a fraction T of income in the form of taxes, that is, the tax function is given by capital T is equals to Ty. This is equation 1. The consumption function as a result is given by C is equals to A plus BYD, or C is equals to A plus B into Y plus R bar minus Ty, or C is equals to A plus B R bar plus B into 1 minus T into Y. This is given as equation 2. While the marginal propensity to consume out of disposable income remains B, now the marginal propensity to consume out of income B into 1 minus T, where 1 minus T is the fraction of income left after taxes. Using equation 2, the planned aggregate demand is now given by AD is equals to C plus I bar plus G bar, or AD is equals to A plus BR bar plus I bar plus G bar plus B into 1 minus T into Y, or AD is equals to capital A plus B into 1 minus T into Y. This is equation 11, where capital A is equals to A plus BR bar plus I bar plus G bar. The aggregate demand schedule given by equation 11 has a flatter slope than the demand schedule given by equation 4. The slope is flatter because households now have to pay part of every unit of income in taxes and are left with only 1 minus T of that unit. Thus, the marginal propensity to consume out of income is now B into 1 minus T instead of B. Equilibrium takes place when AD is equals to Y. Using equation 11, AD is equals to capital A plus B into 1 minus T into Y is equals to Y. Or AD is equals to A plus BR bar plus I bar plus G bar plus B into 1 minus T into Y is equals to Y. Or Y minus B into 1 minus T into Y is equals to A plus BR bar plus I bar plus G bar. Or Y is equals to 1 upon 1 minus B into 1 minus T into A plus BR bar plus I bar plus G bar. This is equation 12. Comparing equation 13 and equation 6, we will see that proportional taxes will lower the value of the multipliers. Income taxes reduces the value of multipliers because they reduce the induced increase of consumption out of changes in income. We can derive the value of the following multipliers from the equation 12. Government expenditure multiplier is equals to alpha g is equals to delta y by delta g is equals to 1 by 1 minus b into 1 minus t. This is equation 13. This is less than 1 by 1 minus b, that is, value of multiplier when there are no income taxes. In other words, magnitude of increase in equilibrium income will be less with proportional income taxation. Similarly, transfer payments multiplier is given by alpha r is equals to delta y by delta r is equals to b by 1 minus b into 1 minus t. This is equation 14. The proportional income tax acts as an automatic stabilizer. An automatic stabilizer is any mechanism in the economy that reduces the amount by which output changes in response to a change in autonomous demand. Swings in investment demand will have a smaller effect on output when automatic stabilizers are in place. Fluctuations in output levels is less. We shall now discuss the effect of changes in income tax rate on the equilibrium income. Looking at equation 12, we can calculate the income tax multiplier mathematically as delta y by delta t is equals to minus by by 1 minus b into 1 minus t. This is given as equation 15. This can be explained as follows. To calculate the change in equilibrium income, we equate the change in income to the change in aggregate demand. The change in aggregate demand has two components. The first is the change in consumption spending at the initial level of income, Y naught, that arises from the tax rate change. It is given by minus b into change in t into Y naught. This is equation 1. Negative sign to show inverse relationship between tax rate and consumption. If there is a cut in tax rate, then change in T is negative and negative becomes positive. That is, consumption spending increases. The second component is the induced spending due to higher income and is given by B into 1 minus T to the power 1 into change in Y. This is equation 2, where T to the power 1 is the new tax rate and change in Y the change in equilibrium income level as a result of the change in tax rate. Total change in aggregate demand must be equal to change in income levels at equilibrium. Thus, 1 and 2 give change in AD is equals to change in Y is equals to minus B into change in T into Y naught plus B into 1 minus T to the power 1 into change in Y, or change in Y minus B into 1 minus T to the power 1 into change in Y is equals to minus B into change in T into Y naught, or change in Y into bracket starts 1 minus plus b into 1 minus t to the power 1 bracket close is equals to minus b into change in t into y naught. This is equation 16. Or change in y by change in t is equals to tax rate multiplier is equals to minus by naught by 1 minus b into 1 minus t. This derived multiplier is the same as in equation 15. Thus, an increase in tax rate lowers the equilibrium income level and a decrease in tax rate increases the equilibrium income levels. Now we will discuss the budgetary surplus. Budgetary surplus is the excess of the government revenues consisting of taxes over its total expenditures consisting of purchase of goods and services and transfer payments. That is, BS is equals to T minus G bar minus R bar. This is equation 17. A negative budget surplus, an excess of expenditure over taxes, is a budget deficit. Assumption proportional income taxation, that is, capital T is equals to Ty, we can write equation 17 as Bs is equals to Ty minus G bar minus R bar. This is equation 18. Figure 3. At low levels of income, budget is in deficit. As income rises, tax collection rise and exceed the government expenditures, making for a surplus in the budget. Budget deficit depends not only on the government policy choices reflected in the tax rate small t, comma, purchases capital G and transfers capital R, but also on anything else that shifts the level of income. For example, increase in investment demand will increase income levels and hence the tax revenues, thereby importing the budget deficit. However, government has done nothing that changed the deficit. Moving ahead and study about the effect of government purchases on the budget surplus. Change in government expenditure changes the aggregate plant demand by change in AD is equals to change in autonomous government expenditure plus induced change in spending due to change in income levels, or change in AD is equals to change in G plus B into 1 minus T into change in Y. At equilibrium, charge in equilibrium income will equal the change in aggregate demand, or change in AD is equals to change in Y is equals to change in G plus B into 1 minus T into change in Y, or change in Y minus B into 1 minus T into change in Y is equals to change in G, or change in Y into bracket 1 minus b into 1 minus t bracket close is equals to change in g, or change in y is equals to 1 upon 1 minus b into 1 minus t into change in g is equals to alpha g into change in g. This is equation 19 using equation 13. An increase in government purchases increases the government expenditure but also increases tax revenues as income levels are increased. Using equation 18, change in budgetary surplus is given by change in BS is equals to T into change in Y minus change in G is equals to T into alpha G into change in G minus change in G, which is equals to T by 1 minus B into 1 minus T minus 1 into change in G, which is equals to minus bracket 1 minus B bracket close into 1 minus T divided by 1 minus B into 1 minus T into change in G, which is less than 0. This is equation 20. Or change in BS is negative. Thus, an increase in government purchase will reduce the budget surplus but by less than the increase in purchases. This is because some part of the increase in resulting incomes is brought back as tax revenues. Next, we will study the effect of tax rate changes on the budget surplus. An increase in tax rate will reduce the level of income as shown in equation 16. The effect of budget surplus is the sum total of the change in the tax revenues at the initial income level plus tax yield at the change in income level. That is, change in BS is equals to change in T into Y naught plus T to the power 1 into change in Y. Or, using equation 16, change in Bs is equals to change in T into Y naught plus T to the power 1 bracket minus B into change in T into Y naught divided by 1 minus B into 1 minus T to the power 1 bracket close. Or change in Bs is equals to change in T into Y naught minus change in T into Y naught into B divided by 1 minus B into 1 minus T to the power 1 bracket close. Or change in Bs is equals to 1 minus B into change in T into Y naught divided by 1 minus B into 1 minus T to the power 1, which is greater than 0 and is given as equation 21. Or change in Bs is positive as proved in equation 21. An increase in tax rate improves the budget surplus. We shall now discuss multiplier in an open economy. In an open economy, exports are exogenously given and imports are given as a function of countries' income levels. Exports X is equals to X bar. Imports capital M is equals to capital M A plus M Y, where M is the marginal propensity to consume foreign goods. In an open economy, consumption function is C is equals to A plus B into Y minus Ty plus R bar, where B is the marginal propensity to consume both domestic and foreign goods. Hence, B minus M is the marginal propensity to consume only domestic goods. Aggregate demand schedule is given by AD is equals to C plus I plus G plus NX, or AD is equals to A plus B into Y minus Ty plus R bar plus I bar plus G bar plus X bar minus capital MA minus MY. At equilibrium, AD is equals to Y. Hence, Y is equals to A plus BR bar plus I bar plus G bar plus X bar divided by 1 minus B into 1 minus T plus M. This is equation 22. The government expenditure in an open economy is given by alpha G is equals to delta Y by delta G is equals to 1 by 1 minus B into 1 minus T plus M. This is equation 23. Value of multiplier reduces with trade. This is because some part of the increased income levels is spent on foreign goods and hence withdrawn from the circular flow domestically. Trade balance is the value of export minus value of imports. That is, TB is equals to X minus M, or change in TB is equals to change in X minus change in M, or change in TB is equals to change in X minus M into change in Y, or change in TB is equals to change in X minus M by 1 minus B into 1 minus T plus M into change in X. Since M by 1 minus B into 1 minus T plus M is a fraction, trade balance improves with increase in exports.
We shall now summarize what we have learned. The existence of a deflationary gap in an economy calls for a government to play an important role in increasing the aggregate planned demand. The government affects the level of equilibrium income through its fiscal policy. In a lump sum tax model, government expenditure multiplier is equals to alpha G is equals to delta y by delta g is equals to change in y by change in g, which can be written as alpha g is equals to 1 by 1 minus b. The tax multiplier is equals to alpha t is equals to delta y by delta t is equals to change in y by change in t, or alpha t is equals to minus b by 1 minus b. Transfer payment multiplier is equals to alpha r is equals to delta y by delta r is equals to change in y by change in r, or alpha r is equals to b by 1 minus b. When taxes fall by a lump sum amount, it does not directly increase the planned demand by the same amount. Fall in taxes first increases the level of disposable income by an equivalent amount. Tax multiplier is always 1 less than the government expenditure multiplier. The balanced budget multiplier is equals to 1 in a lump sum tax model. In the proportional tax model, government expenditure multiplier is equals to alpha g is equals to delta y by delta g is equals to 1 by 1 minus b into 1 minus t. This is less than 1 by 1 minus b, that is the value of multiplier when there are no income taxes. In other words, magnitude of increase in equilibrium income will be less with the proportional income taxation. Budgetary surplus is the excess of government revenues consisting of taxes over its total expenditures, consisting of purchase of goods and services and transfer payments. The government expenditure in an open economy is given by alpha g is equals to delta y by delta g is equals to 1 by 1 minus b into 1 minus t plus m.